are used to analyze these very large data sets to find relationships between the data so that we can make better future decisions for a company or organization, therefore making it more successful and profitable. Now we're going to go on and look at the steps to implement these big data projects. The steps are as follows: data collection, data ingestion, data analysis, data visualization. So first we're going to look at data source discovery, data collection, and data ingestion. The first stage in implementing any big data project is discovering and identifying different sources or applications from which you can collect the required data. Data can be captured from a variety of raw data sources like social media, web and application logs, databases, transactional data, streaming data, sensor data, network data. These raw data sources are categorized into two types, which are real-time data sources and batch data sources. Examples of real-time data sources are social media and sensor data. These are sources that update their data regularly. Batch data sources examples are logs and relational databases. And these are data sources that update after longer periods of time. One can start from using a data warehouse. A data warehouse is a large collection of business data used to help an organization make better decisions, thus becoming more profitable. Prioritized data sources depend on the data required for the analysis. For example, if you want to analyze weather patterns, you're going to have to use data sources that are specific to weather. Now we're going to look at various data collection methods that can be used. Data collection methods are divided into two: qualitative, which is non-statistical, and quantitative, which is statistical. Qualitative data collection methods aim at answering the why question, while quantitative aim at answering the how much question. These data collection methods can further be divided into primary data collection and secondary data collection. Primary data collection are whereby the data is gotten from the original source, whereas secondary data collection is whereby we use readily available data. Examples of primary data collection methods are through surveys and interviews, while examples of secondary data collection are magazines, applications like Kaggle, newspapers. Some of these data collection methods are interviews, questionnaires and surveys, observations, documents and records, focus groups, and oral histories. Data ingestion is a process whereby data is collected from the source and into the big data stack. Data access connectors include tools and frameworks for data collection and ingestion into the big data stack. The big data stack contains a data storage block, which includes distributed file systems like Hadoop distributed file system, and non-relational databases like HBase, which store collected raw data. It also contains batch analytics block like Hadoop or MapReduce, real-time analytics block like Spark streaming frameworks, and interactive querying like Spark SQL. The data access connectors to be used in ingesting data from the various data sources depend on the category of the data source and type of data. These data access connectors include database connectors like Apache Scoop, messaging queues like RabbitMQ, custom connectors like Internet of Things connectors, source sync connectors like Apache Flume, publish subscribe messaging frameworks like Apache Kafka. Now we're going to move on and look at the second step, which is data pre-processing. Data from the various raw data sources may be dirty and contain noise, such as corrupt records, missing values, redundancies or duplicates, inconsistent units, typos, incorrect formatting, among others. These need to be resolved before data is processed. Data pre-processing involves data cleaning, integration, wrangling, and data discretization as a part of it, and other tasks like deduplication, normalization, sampling, and filtering. Data cleaning eliminates the incorrect values and detects any data inconsistencies and missing values. Data integration combines data from people, databases, files, and different sources, reconciling them to come up with a single unified view for decision support. Data wrangling, which can also be called data manging, involves transforming the data from one raw format to another that fits the format of the destination data system and is consistent and more usable for analysis. Data wrangling involves data mapping to link data from the source to the destination data system. Then data reduction, which elaborates the data into a structure that is much smaller. Normalization is also important in cases where different abbreviations have been used for the same entry and they are inconsistent or they are inconsistent units. For example, when we are analyzing a retail store in Zimbabwe, where we have product prices from one store recorded in US dollars and from another source in RTGS, these units must be converted for consistency so that the data can be more useful to the organization. Filtering and sampling may be useful when we want to process only the data that meets certain rules. Filtering can also be useful to reject bad records with incorrect or out of range values. Data discretization is a part of data reduction in the process in which constant properties, characteristics, or variables are partitioned to nominal variables, features, or attributes. OpenRefine framework can be used for data cleaning, wrangling, and deduplicating data. MapReduce or Spark SQL frameworks can be used for normalization, filtering, and sampling data. Now we're going to move on to the third step, which is data analysis. Advanced data analytics are used to extract value from datasets, applying advanced algorithms to perform complex analytics on either structured or unstructured data. Big data comes in various forms or types. They can either be structured or unstructured. Analytics can either be descriptive, which aims at answering the question what happened. Therefore, data from the past is analyzed to understand what could have happened. Diagnostic analytics, which answers the question why did it happen. Analysis of past data is used to diagnose the reason why an event occurred. Predictive analytics, which answers the question, what is likely to happen? It involves the prediction of future occurrences of an event, upcoming risks, or the likely future outcomes by studying the available historical data and trying to find any links or patterns using prediction models. Prescriptive analytics, which answers the question, what must we do now? This is used in decision making by companies. An analysis method is selected and implemented using algorithms. Different analysis methods that can be used are basic statistics, regression, clustering, classification, pattern mining, time series analysis, dimensionality reduction, text analysis, graph analytics, recommendation. After selecting the analysis types for an application, the analysis mode is also selected, which can either be real time, batch, or interactive. It is chosen depending on the requirements of the particular application. Real time analysis mode is used when the application results require updating very regularly, like maybe after a few seconds or minutes. Batch mode is used when updating is required after longer periods of time. This can be months or years. Interactive mode is used when application allows querying data on demand. KPIs, key performance indicators software, may be installed to keep track of progress and is critical to both qualitative and quantitative analysis research. Now we're going to look at the last and final step in implementing big data projects, which is data representation and visualization. Visualizations help in the analysis process and presenting the results in a way that helps us to quickly and easily understand the data by studying the patterns. There are three types of visualizations: static visualizations, dynamic visualizations, interactive visualizations. Static visualizations are used when you have the analysis results stored in a serving database and you simply want to display the results. Dynamic visualizations are used when results need regular updating, for example, with live widgets, plots, or gauges. Interactive visualizations are used in cases where the application is required to accept input from the user and display the results. Now we're going to look at a couple of examples of Python libraries and frameworks used for visualizations. These include Python Pagel library, which is an easy to use charting library which allow various types of chart visualizations. The second is Seaborn. This is a Python visualization library for statistical plotting. Seaborn is built on matplotlib and makes use of Python NumPy and Pandas libraries data structures. Lightning. This is a framework for interactive data visualizations, which includes client libraries like Python, Java, and other languages. The visualizations can be created using Lightning REST API or one of the client libraries. Visualizations can be in the form of plots, like scatter plot or regression plot, charts like line chart and map chart, graphs like bar graph, heat maps like clustered heat map. Now we have come to the end of our presentation.